Start recording. This week we're going to be talking about sections 23 through 26. So sections 23 and 24, you can see even on this first screen, we're talking about them together because sections 23 and 24 are both about absolute and relative change. So really it's, even in web work, the two sections are very much interchanged. So those two are together. And then sections 25 and 26 are also very similar. So we will we'll go through those four sections pretty quickly today. We'll talk about project 3 and then we'll call it a day. So hopefully we'll get taken care of. But this is your last, I'm going to call it horrible week in terms of heavy workload because you're doing basically 2 modules again this week. But next week we just have 1 module, pretty light week, and then the exam. So we're winding down. So the end is in sight. Keep that in mind, that the end is near. Okay, so we're going to jump in here to sections 23 and 24, absolute and relative change. Now, absolute and relative change are simply a way for you to compare values. And there are 2 different ways to compare the same data. We talk about an absolute change. We talk about numbers. So I'm just going to use a pretty basic example. Let's say that I got a $100 bonus last year, and this year I got a $200 bonus. Well, you can see from 100 to 200 is an increase of $100. So the absolute change would be what I have now versus what I used to have. The absolute change is 100. It's a concrete number. So absolute change always deals with a number. In this case, it's number of dollars, but it's a number. Relative change, darn it, what the heck just happened? There we go. Relative change is a percent. Sometimes relative change is also called percent change. And to find that, and we're going to talk about these formulas here in just a minute, we would divide by the 100. We end up with 1 or 100%, which makes sense, right? Your values doubled. But you talk about them in terms of a percent. Okay, that was a bad example because they both ended up being 100. But the point is, absolute change is a number, relative change is a percent. So talking about formulas, absolute change is found by taking the new value minus the old value. Always, new minus old. So you'll see a lot that I will just write n minus o. If you watch the videos, that's what you're going to see. Relative change is new minus old divided by old. And sometimes people call the old value, and they'll call that the reference value. So because you're always referencing back to the old value. So relative change is new minus old divided by old. And you'll see that that gives us a fraction. And then that fraction we can turn into a percent. So those are kind of the formulas for section 23, which is the straightforward section. All right, let's get into some actual math. Enough of me yapping. So rent for a 1-bedroom apartment was $720 in 2016 and is $740 in 2017. So absolute change is what we're going to start with. Remember, absolute change is new minus old. So half of the battle is recognizing what values you would consider new and what values you would consider old. So what values do you think, what value would you say is new in this one? 740 or 720? 740, exactly. Generally, the most recent year is going to be new, which makes 720 old. So my absolute change is 740 minus 720. What is my absolute change? 20. And because it's positive, right, we would say that's a $20 increase because a positive means it went up. It's an increase. And you all probably already knew that. Well, if rent went up $20, that's an increase. So this is not anything new, it's just a different way of talking about it. Okay, relative change. Remember that relative change is new minus old divided by old. So you'll notice the numerator starts with my absolute change, 740 minus 720, but what am I dividing by? 720, exactly, because that's the old value. Now I want to throw something out right now. You're going to do an Excel assignment dealing with absolute and relative change. Remember that Excel is a big calculator, so you can do all of the math in Excel. But one thing to remember, and this will be important for your calculator too, you might need to put parentheses around your numerator so that it will subtract those values first and then divide by 720. That's important to remember. We want the order of operations to be done appropriately. So you do want to subtract the numerator first to get your 20 and then divide by the 720. What does that come out to as a decimal? Let's start with that. And you can round to whatever you feel most comfortable with at this point. Okay, so if we're going to 3 decimal places, it would be 0.028. So Trish, look at that number past that that 7. I think it's an 8, which means it will round up. So no matter what you round to, you still want to round appropriately. That's important. Yep, good, good, good. Okay, so now that we have our decimal, how do I change that to a percent? What is 0.028 as a percent? 2.8, good. So moving, all right, multiplying by 100% or moving your decimal 2 places, and we end up with 2.8%. So when we're talking about this rent went up $20 in that year, right? There's your absolute change. Or you can say rent went up 2.8% in that year. So you talk about the data in the same way, same data, but in different methods. And so depending on what you're talking about, sometimes one will sound worse than the other. You know, maybe $20 increase doesn't sound so bad, but think about 2.8%. Well, I didn't even get that in a raise, so that just makes it maybe a little worse. Okay. Okay, questions about absolute and relative change? The basic of it anyway. Okay, now moving on to this section, number 3. We're going to do the same exact thing that we just did, but you'll notice the data points they gave us are percents. So we have to be able to differentiate between data values as percents and relative change as percents. You will notice in this problem, in the fall, 12% of adults called in sick. The following spring, only 8% of adults called in sick. These are data, they're just data. 12% of adults, 8% of adults. If you have a percent that is attached to the word either increased or decreased, or it could be the present tense, it doesn't have to be past tense. But if you have a percent increase or a percent decrease, right, those words being used, that signifies relative change. But if you just have data points, 12% of adults, 8% of adults, those are just values. And so when we have values that are given as percents, we call those percentage points. So that when we find absolute change, we're finding a change in percentage points. Okay, I would like you to go ahead and try this one. It might be a little bit tricky, but I want to see what you guys can do. So I'm going to give you a minute. Go ahead and try to find the absolute and relative change using 12 and 8, right? Those are data values. All right, let's see what we can come up with here. For absolute and relative change, for both of them, we have to recognize new versus old. What value did you use for your new value? 8. Good. So 8 is new, 12 is old, because the following spring, that's the most recent. So new minus old, we had 8 minus 12, which gave us a -4 percentage points. Now, somebody, back it up. So Trish, you did the mathematical thing that we've been doing all semester, and you changed your percent to decimals. I applaud you for remembering that we do that. However, in this case, we don't need to, because we're using them as 12 percentage points. We're changing that concept of percent in this case, and we're changing it to almost a point value, because we want to talk about them as values. So we have a -4 percentage points. From 8%, 12%, right? There's the negative 4%. So that's why we don't have to change them to decimals. Technically, it's not wrong because 0.04 is still, I mean, that's as a decimal. But because we changed them to points, that gives them like the value type of a deal. All right, so now when we go down to our relative change, right, we keep the 8 minus 12, and then what do we divide by? We divide by 12. Absolutely. So again, we want to make sure that we're putting that numerator in parentheses. We end up with negative 4/12, which what is that as a percent? Negative 33%. Very good. So, you could say, well, from fall to spring, there was a 4 percentage point decrease, right? That was the absolute change, 4 percentage point decrease. Or you could say from fall to spring, there was a 33% decrease in the percent of adults who called in sick. You can see the 33% decrease just sounds huge, which kind of it is. 12% to 8% is a big drop. Okay, so you see how this kind of works. The first example that we did together was kind of a very, very basic numbers, not too bad. Then this one is dealing with percentage points. But any questions on the new minus old or new minus old divided by old? Questions? Okay, in a nutshell, that's section 23. Pretty much, okay? So moving on to section 24. 24 kind of spends more time talking about percent change in and of itself. Now, when you think, so section 23 that we just did, you're given two values and you're actually finding the change. Section 24 says, well, if you know the relative change, which is the percent change, you can use proportional reasoning, which we have done multiple times in this course, but you can use proportional reasoning in order to find different missing values. So the key is, when we think percents, what number should always jump into your head? When you see percent is always exactly out of 100, which right there, right? So when you see a percent, you think of 100. So 100% is always our reference. All right. So in terms of setting up a proportion, if I see 20% more, well, as soon as I see the percent more, well, percent is out of 100. What's 20 more than 100? What is 20 more than 100? Exactly, it's 120. So you can see half of my proportion would be 100 over 120. And obviously we're missing the rest of the problem, but then the rest of the problem would give us one of these values, and then you find the missing value. It's not too bad at all. Let me change color for effect. 35% less. Okay, well, I still see the percent, which means I'm dealing with 100, but now I'm 35% less than that. So if I have the 100, right, I'm subtracting the 35, and what am I left with? 65. Exactly. Again, there's half my proportion, and I can move on. So when you have more, greater than, anything like that, we're adding to the reference value of 100, and when you have less, you're subtracting. Now, I highly recommend that you follow this process with these problems. Every semester, there are a few people who are like, oh, I can do a shortcut. I know a shortcut. And your shortcut will work about 1/3 of the time. And unfortunately, the other 2/3 of the time, you're going to be off. And there's really, unless you are proficient with finding equation mistakes, it's not going to work so well for you. So I really, really encourage you to kind of stay within this process. Okay, there are 25% less students in math classes when compared to English classes, where there are 800 students enrolled. How many students are enrolled in math classes? So the key is 25% less. What is that going to look like in terms of a ratio if I have 25% less? 75 over 100. Very good. Because less means you take away from the 100. And so 100 minus 25 gives me the 75. Okay. Now, sometimes the other side is going to be a little easier than others to set up. So let's kind of just talk through that for a minute. We know that we are comparing math to English. Based off this problem, we know that 75 is less than 100. So who has less students, math or English, based off the reading of this problem? Who has less students, math or English? Math, yeah, because there are less students in math when compared to English. So math is less, so math will be represented by the smaller number. English is the bigger number. Okay, so my numerators have to all be about math. My denominators are all about English. Okay, so blah, 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 English classes where there are 800 students. So where does this 800 go, top or bottom? Bottom, exactly. That will go in our denominator. And if you weren't sure, the question does say how many students are enrolled in math, so my unknown value x will go in the numerator. Then the question becomes, do you remember how to solve a proportion? Hopefully that answer is yes, right? We cross multiply and divide. And very good, Stacy. We end up with 600 students are enrolled in math classes. All right? So that's how we can use so 25% less, that's a relative change. And if we had taken, new minus old divided by old, hard to determine, we're talking about two different classes, but we could get a 25% relative change. Okay, I want you guys to try one of these. There we go. Okay, you go ahead and try this one. Okay, if we start with 15% more, what does that ratio give us? 115 over 100. Good, because it's more, so it's above. Now we're talking about Sarah and Tina. Who's on top, who's on bottom? Who has more flowers? Sarah's on the top, right? Sarah has more than Tina, so Sarah's on top. So if it says Sarah has 120 flowers, 120 is here, X is on the bottom. Again, we cross multiply and divide. How many flowers does Tina have? 104. When you're done with these problems, right, so you're working, you work it out, go back and look and say, okay, so I have that Tina has 104 and Sarah has 120 flowers in her garden, which is 15% more than Tina. If you had flipped these, you would have gotten that that Tina would have had more flowers than Sarah, and it clearly says that Sarah has more than Tina. So you can figure out, even if you set it up wrong, go back and reread the problem, and that will, tell you whether or not, you screwed something up just by the basis of your answer. Okay? How we doing? Okay. Last one for this section. I want you guys to try this one too. The percent of people who smoke has decreased 8% in the last 10 years and is now 12.5%. What percent of people smoked 10 years ago? So this is one where we're combining our proportional work with relative change and the idea of percentage points. So you have to make sure you're paying attention to which one of your percents is the relative change, because the relative change is the one that you play with 100. All right, give you a minute. Go ahead and try that one. All right, which one of these percents is the relative change? 8 or 12.5? 8 is correct, and the key is decreased 8%. So what does that make the ratio? If it decreased by 8, that means we take 100 minus 8, which is 92 over 100. Now we're talking about currently, right now, and 10 years ago. So now and before. When do more people smoke, now or before? More people smoked when? Before, exactly. So more people, 100 is bigger, so before is when more people smoked, now is going to be on top. Ooh, that W got an extra hump there. So when you see the smoking rate is now 12.5%, that means 12.5 goes on top, and our unknown value of X goes on the bottom, because more people smoked before. So we cross multiply, divide. What is the percent of people who smoked 10 years ago? Yeah, it rounds to 14. You cross multiply and divide. It comes out to be roughly 13.6%, but of course, rounding appropriately, 14% would be fine. So roughly 14% of people smoked 10 years ago, and that's down to 12.5% now, which is a decrease of 8%. Okay, any questions? Absolute relative change, percent change, setting up proportions, anything like that? Of course, there are videos, and I would recommend you watch some of them because, again, sometimes this is a 3.5-hour conversation in a face-to-face class, and we did it in 25 minutes. So we did cut out a lot of different types of examples and some wording. So please make sure you're taking that all into consideration, and you don't think that this 24 minutes is going to cover everything in the packet. Okay. So that's module 13. Now we jump up to module 14. So 25 and 26 get into linear models and scatter plots. So some people hate this section because you remember algebra in high school where you talked about the slope, the y-intercept, linear equations, and that sort of thing. So yeah, that's what we're doing. So you're welcome. So let's just go ahead and refresh anything that you can think of in terms of linear models, slope, intercept, the model itself. Do you remember anything from back in the day when you used to do this? If you used to do this, maybe some of you didn't take a class where you had to. Stacy's got nothing. Anybody got it? Does anybody have anything? Usually somebody, X and Y. Okay, we are going to be dealing with an X and Y. Yes. Anything else? Dots and lines. Those are scatter plots. Yep. Yep. We're going to get to those here in a bit. Anything else? Okay, well, that's a start. So first we're going to start with some basic definitions. Okay, so when we talk about the slope of a line, the slope of a line is another way to talk about the steepness. Okay, Amber, yes, we are going to be talking about graphs a little bit, yes. So slopes are going to talk about steepness. So like this line has a positive slope because you can see it goes up. Pretend these are straight lines, okay? This line also has a positive slope, but you can see it's not as steep. So the slope of graph 1 would be a larger number than the slope of graph 2 because it's steeper. The steeper your line, the bigger your slope. Now these are both positive because they go up. Graph 3 is a steep line that goes down right from left to right, so that would have a large negative slope, where graph 4 also goes down, but it's not as steep, and therefore it would be a smaller negative number. Okay, so that's kind of just what slope is. Now, unfortunately, you're going to have to find it and use it. So there's kind of the bad part for you. So slope is based on ordered pairs, right? So I think it was Trish who mentioned we were going to deal with X and Y. So X and Y are ordered pairs on the coordinate plane, right? A little refresher. So the coordinate plane, x-axis, y-axis. Think of these as number lines. So they go positive in this direction, negative this way, positive up, negative down. So to find slope, you can find slope through any 2 points. So we would call these 2 points x1, y1, the comma in between, and x sub 2, y sub 2. Right? And the little numbers that are next to them simply tell you that they go together. X1 and Y1 are in the same coordinate, or in the same graph, coordinate plane. Same coordinate. X2 and Y2, they're a pair. They go together. So those twos just lock those two, right? It marries them. It's like their wedding bands. They don't mean anything mathematically. It just locks that X and that Y together. Okay? So there's a formula to find slope. The formula is simply y2 minus y1 over x2 minus x1. You might have heard rise over run. We talk about the change in y over the change in x. These are just different ways to kind of think about it. And we can say change because change implies subtraction. And so you can see in our main formula here we are subtracting. You'll see that the y values are on top, x values are on the bottom. So change in y is vertical. So we've got a vertical change on the top and then the horizontal change on the bottom. And so that would give you the steepness of your line. That is the purpose, right? So if you go up and over, you now have your slope. So our slope is generally going to be written as a fraction or perhaps as a whole number. That is generally how we're going to keep it. You really don't want to change it to a decimal. It'll be best for you to keep it as a fraction. All right. Oh, wrong button. So that's kind of your, and of course we're going to talk about this multiple times, so no worries. Your y-intercept is where your graph crosses the y-axis. So if I have, just draw a new coordinate plane here in green, keep our colors separate. So this is our y-axis. The horizontal is the x-axis. So the y-intercept is where your graph crosses the y-axis. Now, if I have a dot here, That dot has an ordered pair of 0, 5. The 0 implies I did not move left or right at all. I simply went up 5. That's where the 5 comes from. Like this one would have an ordered pair of 0, 2. Because I didn't move left or right at all. I just went up 2. This one, 0, now I went down 3, so it'd be negative 3. What do all three of those blue points have in common? 0, exactly. And even more specifically than just a 0, it's the 0 in that first position. And that first position is all about x. To have a y-intercept, x must be 0. That has to be true mathematically in order to have a y-intercept. I hope you're hearing me. X has to be 0. So by concept, it's where your graph crosses the y-axis, which is why x has to be 0. Because as you can see from our 3 blue points, in order to cross the y-axis, you have to have an x value of 0. Okay? All right, so I'm kind of giving you the breakdown of this. And then we get to our linear model. Y equals mx plus b, which I'm sure you've all seen this before at some point in your life, and you have filed it away because it was painful, more than likely. All right, so again, you see the x and the y, which represent every ordered pair on this line. So if this pink line was our graph, this x and y represents every little dot that we could draw on this line. So it's just going to stay x and y. When you write an equation, you should have 2 variables, an x and a y, every time. Now, the m and the b should be numerical values. What does the m stand for? Does anybody remember this from back in the day? Oh. M stands for slope. So your value of slope will always fall right in front of the x, and they're touching. So you're gonna have slope times x, and then this b is the y-intercept. Now you'll notice here where I just put the orange check mark, your y-intercept can be negative. If your y-intercept is negative, then that plus b just turns into a minus b, and that's not a big deal, right? It becomes positive, negative. That's it. Okay. All right, so that's kind of the overarching fast review on linear models. If this is something that you totally have blocked out or you don't remember because it's been so long, or you just always maybe say, I wasn't good at that, please, please, please go back and watch all of the videos that go with this section. Because remember, I'm giving you an overarching thing, and you're going to want to, the more practice you have, the easier it's going to get. We only have another 25 minutes. We're going to get through 2, maybe 3 examples, and that'll be great to get you, get you moving, but you really need to sit down and work through a couple of these so that you have it. Well, I'm glad we're working on it now so that you can finally get it. Okay, so let's go through. Oh, wait, let me go back. Nah, I already erased my drawings. Dang it. Okay, so one thing that I want to, you know what? I'm doing it. I want to go back to the previous page so that I can draw something again, because I think something will also kind of help your comprehension. If I draw a line, and again, I need you to use your imagination that it's a straight line, all right? So everybody get your imagination station gloves on, and we're going to draw a line. Not horrible. I've definitely drawn worse. So think about this. By definition, the y-intercept is where the graph crosses the y-axis. How many times does my blue line cross the y-axis? Now the y-axis, just once, right? Right here. So there is one y-intercept in a line. That's it, one y-intercept. Now the slope tells you the vertical change and horizontal change. Vertical change, horizontal change. Vertical change, horizontal change. So your slope has an unlimited amount, right? Maybe better than unlimited would be it's repeated. I can't spell or write with this mouse today. So your slope is repeated. It happens over and over and over and over, but the y-intercept is only going to happen one time. So when we look at this next problem that we're going to go to on this next page, the cost of a cell phone plan is $30 a month plus 10 cents a minute. You have two values here. We have $30 a month and 10 cents a minute. If we're talking about the cost of your cell bill every month, two values. One of them is a one-time fee. One of them is a repeating or a recurring charge. The one-time fee is always going to be your y-intercept because the y-intercept can only happen once. If something is recurring and it happens over and over and over and over, that's your slope because slope is a constant change. It happens over and over and over. So looking at these two, can you tell me which one of these only happens once a month? We're talking about your cell phone plan for a month. $30 a month or 10 cents a minute. Which one of those only happens once? The 30, exactly. This happens one time, right? You have a plan of $30 a month. So because this only happens once, my y-intercept, this is the answer to letter B, we know that the y-intercept is 30. It happens once. Even if I never pick up my cell phone, I never place a call, my bill is $30, right? So that's the ordered pair would be 0, 30. Because no matter what, even if nothing else happens, my bill is $30. Okay, what does that 10 cents per minute represent? It represents your slope. So your slope is 10 cents a minute. In this case, it's just 10 cents because it's recurring. If I talk for 1 minute, it's 10 cents. 2 minutes, 20 cents. 3 minutes, right? It just goes up. Every minute you talk, it goes up the same amount. So it's a constant change and it happens over and over and over. So that's our slope. Okay, if I have a slope and a y-intercept, I can write a linear model. Okay, so our linear model, right, we're always going to start with a y. Y equals, then we have our slope. We know our slope is 10 cents, followed by my x value. And then I have 30, because 30 is my y-intercept. So you notice the x and the y stay, because they represent every possible combination for the entire month. Everything. Every possible minute you could talk. Represented there. So, what do x and y represent? Well, think about your slope. Your slope is 10 cents. Think about where that number came from. And we want to know what x represents. So if your slope is the 10 cents, what do you think the x represents? The number of minutes, exactly. Because if you talk for 2 minutes, that's 20 cents. If you talk for 20 minutes, that's $2. So it's the number of minutes that you talk. Okay, what does y represent? So that's this piece here. Think about what all of the pieces on the right mean, and what would they add together to get? Your total cost. Very good. All right, so the x is the number of minutes, y is the cost. We would say the cost of our cell phone bill depends on how many minutes we talk. It's true, right? My cell phone bill depends on how much data I use. If I go over my data plan, my bill goes up, right? Okay, so now let's look at E and F are kind of our application problems. So what is the monthly cost when you talk for 76 minutes? What do I do with that 76? I plug it in for x because it's the number of minutes. So I take my formula, y equals 10 cents times 76 plus 30. Remember, order of operations. So you should be multiplying first. 10 cents times 76, get a number, then add that to 30. And what do you get? $37.60. So it would cost you $37.60 for that month's cell phone bill if you talked for 76 minutes. All right. Next one. How many minutes did you talk if your monthly cost is $43? What does that $43 represent? Y. All right, so we plug it into our equation. 43 equals 10 cents times X plus 30. And now we have to solve for X. What's our next step in solving for X? Subtract 30 on each side. Good. So if I subtract 30, that gives me 13 equals 0.10x. And then our last step. Yep, we want to divide by the number in front of x. We divide both sides by 10 cents. So x is 130 minutes. All right, so I call that one kind of a straightforward problem. Straightforward because they give you the slope and the y-intercept. You just have to pull it out, right? You have to understand which is which based off of the problem and how they word the problem. But you don't have to actually do the math to find it. Okay, questions on that particular problem? The more you do, the easier they get. And I know that sounds super cliche, but it's totally true. All right, now let's do one that's a little bit more difficult. The population of a town in 1970 was 5,600, and in 1995 it was 4,100. So we're going to find the slope, y-intercept, linear model, all of that business. But first we have to create ordered pairs, because in order to find the slope, we need an x1, y1, right? We got to have our ordered pairs. And so one thing that I want to draw your attention to, I would say remind you, but I don't know if you've ever been taught this, so this might be new, since I don't know any of your backgrounds. When you're talking about ordered pairs, anytime that you have time is always your x value, and then anything else is your y value, okay? But we're talking about dependent versus independent variables, and so because and we don't get into that in this class very much, but x is independent. You know, nothing depends on time, or everything depends on time, excuse me. Time, you know, you don't say, oh, well, it's January, so therefore whatever. That's just not how it works, right? You depend on time. So time is always the x value. I'm struggling with real life examples on the fly today. You'll have to forgive me. So in this case, do we have anything that represents time? Yeah, the years. The years are time. The population is in respect to time. 1970 is 5,600. So that population depends on what year it is. So I can write two ordered pairs, right? In 1970, my population was 5,600. And in 1995, my population was 4,100. However, I have a problem with that. And the problem is, if I want to write a linear model, go back to the very first slide of this PowerPoint, we know that a y-intercept has to have an x value of 0. And if you look at my two ordered pairs, I don't have a value of 0. Okay, so the nice thing is that you can say, you know what? We are going to let x be the number of years since 1970. And this actually makes the math a whole lot easier because you're dealing with smaller numbers. So we can say, okay, I'm going to say X is the number of years since 1970. That means 1970 has a value of 0. So I'm going to put this over down here. So the first ordered pair is 0, 5600. Because I need an X value of 0. So I'm going to let X equals 0 means 1970. And I'm using that one because that's my earliest year. Whatever you're dealing with, your earliest year should have the X value of 0. Okay, now use your thinking skills. If 1970 has an X value of 0, what will the X value be for 1995? $25. Very good, Amber. Okay, does everybody see why that's true? If you think from 1995 to 1970, how many years are between those? So if you subtract them, you get 25 years. So that's kind of your mindset as you work through these problems. If I had said the year 2000, well then X would be 30 because it's 30 years after 1970. So you always use that very first year as your reference year. Okay, so now that I have two ordered pairs, I've got 0, 5600 and 25, 4100. Without doing any math right now, what do you know? Based off of one of those ordered pairs, what do you know? Well, you have an X value of 0, right? So this value here is your y-intercept. My y-intercept is 5600 because X has a value of 0. That was the sole purpose of changing those ordered pairs so that I have a y-intercept. Okay, now we can find our slope. Remember that slope is y2 minus y1 over x2 minus x1. All right, it doesn't matter which, like I usually just say this is x1, this is y1, this is x2, and this is y2. But it doesn't matter. As long as you're consistent with your little numbers, you're fine. So my y2 value is 4100. And I'm going to subtract my y1 value of 5600. And then in my denominator, I've got 25 minus 0. So notice that the ordered pairs are right on top of each other in the problem. So I end up with negative 1500 over 25. And what does that simplify to? Negative 60. So that means this slope right here tells you every year after 1970, the population in this town decreased by 60 people, right? Because the slope is a constant change. So every year, 60 people left or died, whatever. They just no longer are there. All right, so if I have a slope and I have a y-intercept, which I do, I can now write my linear model. Can any of you give me a linear model for this problem? Okay, what do we start with? There we go. You always start with the y. Next comes your slope attached to your x value, and then we have 5,600 people. So we have this linear model, and the model can be used to predict for future events. So we could say in 1995, they could have used this model then to predict future years. Do we need a Dollar General to come into town? No, because in 20 years, we're not going to have any people, right? That kind of thing. All right, so letter D says use that model to predict for 2017. Okay, well, the question is, what is the x value for 2017? Because remember, in 1970, your x value was 0. So for 2017, what is x? 47, because it's 47 years later. And you can just subtract them. 2017 minus 1970 gives you 47. So we use our model. Y equals negative 60 times 47 plus 5,600. Why does that keep doing that? There we go. Okay. Order of operations, multiply before you add. And what is the approximate population for 2017 for this disappearing town? 2780. Okay. So that's a little bit more difficult of a problem where you have to create ordered pairs, find the slope, write the model, and then use it. But that's pretty typical of, what you're going to have to do. So it's one step at a time. If you know you need a model, what's the slope, what's the y-intercept? You have to have those two pieces in order to write your model. All right. Okay, section 26. There's not a lot in it in terms of doing stuff by hand. It's a lot more Excel work. I will post a video about scatter plots in Excel, just in case you want to kind of get a better feel for that. So I'll post that one as well. But a scatter plot is simply a bunch of data on a graph, okay? Usually dots. Then, if I could change colors here, we add a trend line. And the trend line is a linear, well, usually it's linear, it doesn't have to be, but in our case, we always make them linear, is a linear approximation of the line of best fit. So it kind of cuts through the middle of your data. So in Excel, if you type in your data and you graph a scatter plot, and then you can hit a button, again, I will post a video, where add a trend line, and you can then get the equation on there. So they may say this equation is 0.2x plus 7. And there you go. And then you'll also get r squared is 0.79. I'm just making these numbers up. 797. Okay, so the trend line is just the linear graphic through the middle of the scatter plot. Now, this r squared value is what's called the linear correlation coefficient. And the linear correlation coefficient, well, this is going to lead us to the linear correlation coefficient. R squared is actually the correlation of determination, but that's totally different. Coefficient of determination. So the linear correlation coefficient, which is R, tells you how good of a fit your line is to your actual data. So R is going to be somewhere between -1 and +1. If you have a positive slope, you have a positive R. If you have a negative slope, you have a negative R. That's kind of the big difference between those two things. The closer it is to 1 or -1, the closer to linear your data. So if we go to our green example of r squared is 0.797, how do we get R from r squared? What do you do with that? How do you unsquare something? You take the square root, exactly. So if I square root both sides, I get roughly 0.893. And I leave it positive because this line is going up. Right? You will have to add the negative sign in there. And that's decently close to 1. So I would say that there is a strong linear correlation between the vertical and horizontal groups. Okay. The whole idea of scatter plots, trend lines, and linear correlation coefficients, this is the only stuff in section 26. And the trend lines are linear, which is what you just did in section 25. So really the linear correlation coefficient is the only new piece. I do recommend you watch the videos because as you notice right now, it's 12:54 and we are pretty much out of time. because I want to talk about the third project. So I'm cutting off from there. Hopefully you know where to find the videos because you're supposed to be watching them all along. So hopefully you know where those are at. But right now I'm going to bring up, where is the third project? There it is. Okay, I don't know the due date of the third project for this course, so you might want to look at that. But I think it's part of Module 12. So here's the big deal with financial project. This is my favorite project. I think that you'll like it the best. The basic deal of the financial project is that you're going to choose a career that you want to go into, and you're going to search for your average salary. Okay, so you want to do that based off of where you're planning on living. So if you're going to live in Nebraska, well then search for the average salary of a nurse in Nebraska, whatever, because it's going to be different, depends on where you live, right? A nurse in Nebraska is going to make less money than a nurse in LA. That's just life. So you're going to find your average salary for whatever you want to do, and you're going to compare that to the average salary of a high school graduate. Okay, so notice how it says use absolute and relative change statements in your project here. So that's something to keep in mind. So the first part, you're going to do an income comparison. And I want you to notice these white boxes, these are my rubric. So you want to make sure that you hit all of these pieces when you're doing your write-up, okay? So the income comparison, how much do you make versus the high school graduate? Tell me about it, right? Answer these questions. Then you go to a housing comparison. You're going to need to go to a bank website to figure out an APR. Cite your sources. Where did you find your average salary? Where did you find the bank APR? How did you figure out how much house you can afford? How much house your counterpart can afford, your high school graduate? Then you're going to answer these questions. Notice this last one says, research housing costs in an area where you would like to live. I mean, if you're living in Claypool and you like that, great. Right, talk about that. But if you're like, you know what, my dream would be living in Hawaii, right? You can make this as far-fetched or as factual as you want. It's your project, okay? And then the third and final piece of this project is retirement comparison, which is section 22. Okay, so you're going to talk about you get a 5.99 annual return, blah, blah, blah. And again, you're going to answer these 3 questions based off of that information. There's only, I think, 8. Yeah, there are 8 little white boxes. Those are the 8 pieces I'm grading. So each one is basically worth 12 points. You skip one of them, you're down to a B. You skip 3, and it's going to be ugly, right? So you want to make sure you hit those pieces. Now, the one thing that I want to tell you, you don't have to turn in an Excel document with this because they tell you, explain what Excel function you used. You're going to actually type out the Excel function, so I don't need to look at your Excel. I can just look at your formulas and make sure you did them correctly. But if you don't want to write a paper for this, you don't have to. You can do a PowerPoint or something like that. If it's not a paper and it's not a PowerPoint, I just would ask that you email me and say, hey, is it okay if I do this? I'm pretty easygoing on this project. You can come in and give me a presentation if you'd like. I don't care. But if you don't, some people really like to make PowerPoints. They think that's a whole lot more fun than writing a paper. I don't care how you get me the information, but you better hit all 8 of these white boxes for me to be able to give you full credit. Okay, so that's the third project. It's due sometime in the second week of May, I believe, before finals. So you might want to get a jump start on that when you can find a minute. I know that it's a lot of work right now in this class, but in 3 weeks it's over. So keep your head above water and keep working. So, okay, it's 12:59. Does anybody have any questions for me, either dealing with something from today or the third project? No, you do not have to narrate your PowerPoint. Nope. I can go through and read it. As long as you have all of this information on it, you're fine. Yeah, totally fine. And you can make a video. I mean, if you wanted to, you could totally do a video of some type if you wanted to. I would be okay with that as well. But you don't have to. You can simply do a straight up PowerPoint. Totally fine. Yep. Any other questions? Okay, well, I'll stick around for a few minutes if anybody has any. Otherwise, we are officially done. Have a great day. Have a great week. Keeps emailing me questions. Some of you are great at asking questions, and I know I'm a little behind. I didn't check my email after 6 p.m. yesterday, so I've got some emails to get back to from last night, and I've been in meetings all morning, so hopefully I can get those done today. Yeah, but if you have any other questions, let me know. Otherwise, have a great week, and I will see you back here next week for just 2 sections, right? An easy week next week. So keep up the good work and let me know how I can help. Thanks, guys.